Fractional exponents. So use your calculator, do 1A and B in your calculator, and I'm going to pause this now and fill them in, and then we'll compare. Okay, so based on what we can see in the table here, it would appear that a fractional exponent of 1/2 is the same as taking the square root. So an exponent of 1/2 is the same as taking the square root. Okay, let's try that out. 16 to the 1/2. So we think that should be the square root of 16, which is 4, and 49 to the 1/2 would be 7. Okay, let's check that out on our calculator. Clear. 16 to the power of 1/2. 4, 49 to the power of 1/2, 7. Now if you remember earlier from inverse operations that every number can be written as the square root of its square. So we're going to use the exponent law to show that this is true. So remember that 7 can be written as the square root of 7 squared, which is the square root of 7 squared. And using exponent laws, the square root of 7 can be written as 7 to the 1/2, power to a power, makes this 7 to the 1/2 times 2, or 2 over 1, which is 7 to the 1, or just plain old 7. Let's take a look at an exponent of 1/2 in more detail. Use the exponent laws to simplify the following. 6 to the 1/2. Multiplying powers with the same base, we add exponents. 1/2 plus 1/2 is 1. So we get 6 to the 1. Now use radicals to show this is true. Well, 6 to the 1/2 times 6 to the 1/2 is the square root of 6 times the square root of 6, which is the square root of 6 times 6, which is square root 36, which is 6. Alright, now let's evaluate each of the following. 2 cubed is 8. 3 cubed, 27, 64, 125. So, what's the cube root of 8? 2. The cube root of 27. Think inverse operations. 3, 4, and 5. Oops, wrong way. Use your calculator to evaluate the following. 8 to the 1/3. Now let me just slide this over. 8 to the power of 1 divided by 3. 2. 27 to the 1/3. 64 to the 1/3. And 125 to the power of 1/3. So 3, 4, and 5. Pair the three tables. What do you think an exponent of 1/3 means? So here, let's back up. 2 cubed is 8. Cube root of 8 is 2. So comparing all of these, we can see that an exponent of 1/3 is the same as cube root. So an exponent of 1/3 is cube root. Don't forget you need the index 3. Test this theory out by evaluating the following. Well, we actually already did these. So that's 3. That's 5. And we did them up here. So we know that to be true. So what do you think an exponent of 1/4 means? Well, I would say that x to the 1/4 is the 4th root of x, right? Index of 4. So the 4th root of 16 should be 2, and the 4th root of 81 should be 3. And if we're going to test that out, slide this over, so 16 to the power of 1 divided by 4 is 2. 81 to the power of 1 divided by 4 is 3. And we've got this pattern going on here. So we say that a to the power of 1 over m is the mth root of a, right? The index here is m. But what if we don't have 1 over? What if we have 8 to the 2/3? Well, can we split that up? Can we write it as 8 to the 1/3 squared? Yeah, the power to a power law. So power of a power says that when you have a power raised to a power, you multiply the exponents. We'll be multiplying 2 times 1/3. So from here, we can say that 8 to the 1/3 squared is the, well, 8 to the 1/3 can also be written as a cube root. That's supposed to be a 3. And it follows that the cube root of 8 squared is the same as the cube root of 8 squared. Now, that sounds the same, but I mean the cube root of the, or sorry, the square of the quantity, which is the cube root of 8, is the same as the cube root of 8 squared. Square the 8 first, then do the cube root, or do the cube root first and then square. Now, I think for us, it's easier to do roots first. So when we're doing this, I would think of it as the cube root of 8, which is then squared, which is 2 squared, or 4. And here, I would think of this as the 4th root of 16. Now, I could put the cubed here, but I don't even know what 16 cubed is. I would have to work that out, and I'm not going to do this. We're going to do this without a calculator. So then we'll cube. The 4th root of 16 is 2. Cubed is 8. Verification, so we want 8 to the power of 2/3. 8 to the 2 divided by 3. We get 4, and we want 16, whoops, to the power of 3 divided by 4. The 4th root of 16 is 2, cubed is 8. Okay, so we have verification on the calculator that this is true. In conclusion then, we say that a to the m over n is the nth root of a. Take the root first, then raise that to the power m, or order of operations wise, you do exponents first, so you would raise a to the power of m and then take the nth root. This is the easily doable without a calculator form. So let's change from radical form to exponential form here. We have the cube root of 4 squared. That's 4 to the power. Now we put the base, the root, it goes in the denominator. So I always say what root, a cube root, and then to what power squared. So we get 4 to the 2/3. Let's do these. So it's the negative of the cube root of 27. So 27 to the 1/3. And here it's the cube root of, and then I want to square those. So the base of the power is 64 over 125. Put it in brackets because it's a quotient, And again, the power goes up top. What power? What root? So filling this in, what root? This is just a root. It's a cube root of -8, which is doable because we can take the cube root of a negative. This is the fourth root of 81 cubed. So fourth root, 81 cubed, right? And we can write that in two different forms, right? We could also write it's the fourth root of 81, and then we'll take that quantity and we'll cube it. This is the negative of. Notice the negative is not in brackets, so it's the negative of the square root, 2, that's what root, of 4 to the 5th, or it's the negative of the square root of 4, then raised to the power 5. And actually, I've got that bracket in slightly the wrong place. So let me fix that. It's the negative of. Okay, so this negative operates after this is done. Here, this negative is inside the bracket, so we are doing the cube root of -27/8 to the power of 7, or the cube root of -27/8. So we're going to do the root first, then raise that to the 7th power. Right, so we can work these either way, right, just like above here. We can take the nth root of a and then raise that to the power of m, or we can raise a to the m and then take the nth root. And it just really depends on what we're doing. Write the following in radical form first. So actually what we're going to do is start with these. Is 0.2 is 2 over 10. So we're going to change it to a fraction. And 2 over 10 is 1/5. So we're writing it in radical form. That will be the 5th root of 32, which is 2. This is 81. 0.75 is 3/4. So that's the 4th root of 81. Now I'm doing this without a calculator, so I don't want to put the cubed in here. I have no idea what 81 cubed is. But the 4th root of 81 is 3. Cubed is 27. Without using a calculator, evaluate the following and write the answer as an exact value. So I'm doing roots first. It's the square root of 16 cubed, which, square root of 16 is not 2, which is 4 cubed, which is 64. Cube root. So change it from exponential form to radical form. It's the cube root of 27. Then raise that to the power 4, which is 3 to the 4, or 81. The negative's in brackets, so we're going to do the 5th root of -32 and then cube that. Remember, so this is what root? What power? Right. Cube root raised to the 4th power. Square root raised to the 3rd power. 5th root raised to the 3rd power. The 5th root of a negative can be done. This is -2 cubed, which is -8. Slide this up. So this is the negative of, right? It's the negative of the square root of 4 raised to the power 5, right? We're going to do this first and then multiply by -1 in essence, or just take the negative of that. So it's the negative of 2 to the 5th, which is -32. this is the cube root of 64 over 125. So we know these, right? That's why we did that whole intro thing, was to become familiar, so that we would know that 64 is a cube, right? That it's 4 cubed. 125 is 5 cubed. So I take the cube root of 64 over 125, get 4 over 5. We're going to square that, and we get 16 over 25, right? And that is the answer as an exact value. And here we have a negative inside the bracket, so we are going to do the cube root of negative 27 over 8, and then raise that to the 4th power. So the cube root of a negative is negative. This will be negative 3 over 2 raised to the 4th power. This will now become positive, since when you raise a negative to an even power, the negative signs pair up to make positives, and we end up with 3 to the 4th over 2 to the 4th, or 81 over 16. What about negative exponents that are fractional? Well, you'll remember that a to the negative n is 1 over a to the positive m. Do you think it'll make a difference if the exponent is a fraction? Let's take a look. Use your negative exponent law from above to evaluate the following without a calculator. So 4 to the 1/2 is the square root of 4, which is 2. This will be 1 over 4 to the 1/2, which we already know is 2, right? We don't need to really work this out further. It is 1 over 2. 9 to the 1/2 is 3. This is equal to this by this. I mean, this is 9 to the positive 1/2. Make a negative exponent positive by taking the reciprocal, which is 1 over 3. So does it matter if the exponent is a fraction when using the negative exponent law? No, because we can still take these roots. Also, a big one, at least one that can be a big time saver, is when you are taking a fraction or rational expression to a negative exponent, you can simply take the reciprocal of that. So here what we do is we take the reciprocal. We take 4, the reciprocal of that's 1 over 4, and we make that 1 over 4 to the positive 1/2. Here we just flip the original expression, the original fraction. Okay, evaluate each of the following without a calculator. This is 1 over 8 to the 1/3. You really can't do anything with a negative exponent. You have to turn it positive. Let's make that a big 8. And that's cube root of 8. So we'll get 1/2. This is, so first we're going to turn this positive. So it's 1 over negative 32. The base will stay the same. That won't change because we move it, but moving the expression into the denominator makes this a positive exponent. So it's 1 over the 5th root of negative 32. So do that first, then square it. So it's 1 over negative 2 quantity squared, making sure that's in brackets, which gives us 1 over 4. And I sort of shortcutted this, right? It should be 1 over the cube root of 8. Negative 216. Now remember, the negative will happen after this. Exponents say do that first. So we have a negative sign. Then we have 1 over 216 to the 2/3. We change a negative exponent into a positive exponent, but the expression goes to the denominator, and then there's this negative waiting to be applied. So, evaluate this. Well, it's the cube root, so it's the negative of 1 over the cube root of 216, and then square that, which is the negative of 1 over 6 squared, and so we get negative 1/36, right? So this negative just means it's going to be negative, right? We evaluate it first, then we make it negative, because that's applied at the end. Okay, 4/3 to the negative 2. Okay, so we have a fraction. we take the reciprocal. It becomes 3/4 squared, which will give us 9 over 16. 16 over 81 to the negative 1/4 becomes 81 over 16 to the positive 1/4, which is the 4th root of 81 over the 4th root of 16. Okay. 4th root 81, 4th root 16. And actually, I guess what precedes that is overall the 4th root of 81 over 16. So here's a whole pile of, it's acceptable for me if you go from this to this to this. 4/9. Okay, it's a fraction to a negative exponent. We take the reciprocal and we turn the exponent positive. It's the square root of this cubed. So it's the square root of 9/4, then cubed, or we have to cube these, and I don't want to do that. We don't need 729 over 64. So we'll take the square root of this, which is 3 over 2, and then cube it, giving us 27 over 8. In this case, the negative is inside the brackets, right? So we're going to maintain that negative. We're going to take the reciprocal of the fraction and turn the exponent positive. So the cube root of this, right, because that's what it is, it's the cube root of negative 125 over 64. And then we're going to square that. So the cube root of that is 5 over 4. Okay, and it's actually negative 5 over 4, right? Cube root of a negative is a negative squared, which becomes positive now 25 over 16. Okay, a couple more. Reciprocal. This is just 8. Oops, and this is positive. Are you sure? I'm positive. No. Let's clean it up, move it up being close. Okay, so it's the cube root of 1000 over 125, then squared, which is 10 over 5 squared, which is 2 squared, which is 4. Actually, if we look at this, you might have recognized, hey, this is 8. 8 to the 2/3, right? Which means the cube root of 8, 2 squared, which is 4. So you might want to simplify earlier if you can. Here's an application. Where do we use this in real life? The time it takes a pendulum to make one complete swing is given by t is 2 pi 10 over L to the negative 1/2, where t is the time in seconds for the swing and L is the length of the pendulum measured in meters. Determine the swing time for pendulum with a length. Okay, so this is supposed to be meters. So 160, clean that up. 160 centimeters times, put centimeters on the bottom, meters up top. 1 meter is 100 centimeters. These cross off. This becomes 1.6 meters. You could go there straight away. I don't need to see this take place. So t is 2 pi 10 divided by 1.6 to the negative 1/2, which is 2 pi 1.6 over 10 to the positive 1/2. Okay, this is actually getting a little bit easier to calculate. So that's 2 pi. 1.6 divided by 10 will be 0.16 to the positive 1/2, the square root of 0.16 is 0.4. And so we get 0.8 pi. This is exact. Okay, keep in mind this is t all along, t, t, t. And if you evaluate that, the time would be 2.51 seconds, rounded to the nearest hundredth. Okay, and it didn't mention rounding, but we're going to round it to the hundredth. Okay, that's blank. Let's go fill in the last line of our exponent table. Remember, back to the table. There's really not much we can give here, I don't think, but when a base is raised to a fractional exponent, the numerator of the exponent becomes the power of the base, and the denominator becomes the index of the radical. Okay, or I think of it as the root. So a to the m over n is the nth root of a to the m, or it's the nth root of a, and take that quantity and raise it to the m. So this is the square root of 9 cubed, or the square root of 9 cubed, which is 3 cubed, or 27, as opposed to having to do the square root of 729, which is also 27. And that is it for fractional exponents and the last law of the exponent table. And we'll work on variable bases in the next lesson.